So are there any questions on that? So you figured out and you guys learned that images are just a set of pixels. So somewhere along the way, when we were doing this handwritten text, it figured out, what does 7 look like? Like how can different representations of a 7 with a dash through it, or a 7 like this, that they're all sevens, that even if the one is detached, the part of the one is detached, like they're all different representations. We have people in Germany, people in India, people all over the world who write numbers or grow up learning how to write numbers in different ways. And we need to be able to figure it out. It's almost like you can have these apps where, even if I've been a teaching assistant in undergrad where I had to grade students, some who had very sloppy handwriting. It's not like I had the best either. I write in cursive, but like some students had really horrible handwriting. Imagine having these apps that can reliably predict what they have written, right? Like, and even for writing these equations by hand, if you had to write it by hand, it would take you some time. Like I actually, before I knew about this, what I typically do is I actually go through it and I write equations like this. So I would have to write 100. I would have to manually fill this out this way. And depending on what's easier for you, it could take you some time. I've gotten quite good at this now with practice, but imagine if you really don't want to have to write this. For you guys, no offense, but it's going to take you guys longer than for me. I've just written this a ton throughout my math career. I'm a math major. I've majored in math, so I've written this a ton, so it's faster for me. But for you guys, this might take you guys a while to get used to. Not a while, but like you have to figure out where the summation is, where the fractions are. So I'm just showing you, like, it will take you a while. So you might want to opt for the handwritten to this, because you need to figure out how to do this. So that's what I'm saying. They're making life easier for you guys. And that's all from training, from recognizing, from lots of pixels. After a while, what these things will recognize is, okay, well, what are characteristics of, you guys can see my screen, right? Oh, okay, I'm looking for the annotation here. Okay, so after a while, they're going to learn characteristics, pixels that may be an S, like we looked at. They are going to notice that an S typically has like lots of pixels like this, something like this. If it meets this criteria, where maybe in this region, it's like really dark, 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 dark. Like in this, if it looks at patches and then sees, okay, this patch must be dark, dark, dark. There must be some white space here and here. And maybe they can look at, they also have neurons recognizing an 8 too. So how can you determine what's an S, what's an 8? Then what they will notice is that the 8 also has something going on over here typically. They need lots of images to figure out these patterns. Because at the end of the day, it's just a set of patterns. Like, how does our mind know what an S is? How does our mind know what an 8 is? If we can turn that idea into math, we can see it in front of us. We can visually see it and process it. But the idea is that if we train like a network, a neural network, to know which pixels, how those work mathematically, there must be a way that we can train a program to also recognize it, because there is some truth behind this madness, so to speak, that we learned it, we figured this out as kids. And there is something that we can look in these images and recognize it. And they even have neural networks to predict, and I did a project on this for my school, and it is like CT scans, COVID-19. They have these chest scans of people with COVID. So this is the machine, and people go into these machines, like these revolving machines, and they get their chest x-rays and stuff. You can see patients going in here. And radiologists look at these CT scans to figure out if people have COVID or not. They look at all of these. And they have neural networks that are trained to, based off of these images, to recognize, does a patient have COVID or not. So what they do is radiologists. So that's what supervised is so much with, like supervised machine learning, and there's unsupervised and reinforcement learning. But what makes supervised so hard is because you actually need a radiologist. If it's unsupervised, and you could say, oh, I noticed that these images have like some specks here, like these are white specks or something that they have. And you could probably notice some patterns, but you might not know what's what. You'd be like, I think these are like These images could be this. I just don't really know, but I'm noticing that some images have these, some don't, right? Like you might yourself come up with groups. But supervised is when you actually have a radiologist who's gone through and labeled hundreds of these of COVID. So you look at these scans with COVID and you look at scans without COVID. And if I looked at it, I'm no doctor, but if I looked at it, I may not know. But if a radiologist looks at this and can figure out who has COVID and who doesn't, there must be a way how they can look at an image and figure this out. I bet that if I may not figure it out, but if I give it to a model, a machine learning model, I can give them thousands of images, a model, and they can learn on those thousands of images. It can learn from them. And at some point, it's going to see what the doctor can see, hopefully, if I give enough data. It's going to see, like of these images, it's going to see what the doctors can see. It's going to figure out some pattern, because if I give a bunch of images and say these were ones a doctor labeled as having, radiologist labeled as COVID, chest scan, so these are the lungs, guys, these are lungs. And these are ones that the radiologist labeled as not COVID, a bunch of images, like maybe thousands. Then these models, if they get more data, they can sort of figure out what is it behind the scenes. Why did the doctor say that? So I, as a layperson, unless I go to medical school, get trained in radiology and go through all that, residency, I may not recognize why. I can't look at 1,000 images, right? If I wanted to, I could study 1,000 images, note down a bunch of patterns, and then see if those are right, right? But how can I look at 1,000? I'll go crazy, right? But a model can look at 1,000 images. It can figure out patterns. So we give it to the model. So if a radiologist is saying, hey, these are a bunch of things I said are these samples, these are a bunch of things. And then I could say, oh, okay, so it looks like these white dots are like COVID. And then the radiologist would say, no, sometimes it can be a sign of this, random, like this, like some technical medical jargon that I won't know, right? And then it says, well, if you see this thing, you must also see this. And I will be like, oh, okay, I don't know. Like, okay, I made an assumption. So the idea is that you need to give thousands of images, and somewhere these pixels of these images are picked up. Like how we saw the S is a bunch of pixels. They are picked up and they're turned into math. Models are learned. And they will figure that out, hopefully, if they're given enough data that's supervised. And the goal is that in the future, if radiologists are busy, you can have an app that instead you can upload, instead of uploading a face with pixels, you can, no, a face with mask or without mask, you can upload a CT scan. And you can quickly have an assistant maybe sharing this with the doctor and saying, okay, I think these patients definitely don't have COVID. I think these ones definitely may have COVID, and you should check those out. Maybe these ones are iffy. So maybe instead of looking at 100 patients CT scans, a doctor just has to look at 20. You can cut down the work. That's a goal, but doctors also have reservations and as well. But if you tell them that this is trained on thousands and thousands, and they'd be happy to use it, especially in COVID where people were flooded, doctors are flooded and stressed, and maybe they need to prioritize which patients to give, treatment, intensive care treatment to, right? They would probably want to take the worst case patients if you can have something that can predict it. The idea is that radiologists can look at an image. They can make a classification. Do you have COVID or not? There must be a way that we can represent whatever they've learned in data, in numbers. There must be a way. That's the idea behind this. So we learn what is deep learning, but why does it work? So in machine learning, when we talked about how deep learning is one of the well-performing techniques in machine learning, but in machine learning, we need to actually think about the features before we make predictions. We actually need to think about we need to do feature extraction. So if we're trying to make predictions, like on a house, for instance, we need to actually do that work. So do you guys have questions on this so far? So deep learning is end-to-end training. So in deep learning, it can extract features by itself. In machine learning, we can predict the value of a house or if this is a car or not. So I know it may not have been as confusing, but we talked about features like for the house price, we can see, the neighborhood it was built in, number of rooms, sizes. What about for a car? What things do you guys think we could use to predict if something is a car? Wheels, windows. Yeah, and then you have to also think, okay, does it have a wing? Nope. I mean, as of now, as of 2021, cars don't have wings. Who knows if that changes, but the future, if people want to make those types of things come true. But as of now, cars do not have wings. So you'd have to specify in your model like what features. If I want to predict, your SAT scores or your grade point average or price of a home or the chance you would like a movie, or the chance that you'll watch this video on YouTube. I have to actually sit there and figure out what features to figure out, right? Like what I choose to figure out the price of a home might differ from what Kana wants, or what David, or what Jaxie, or what Suba, or Karen, or Lachlan, what you guys may choose. It's different person to person, but like I have to sit there and think about what features I want to get for my model, like what I want to include. Do you see what I mean? Like what data I want to measure if I'm predicting the price of a house. But for deep learning, did you guys think I extracted any features like to predict if somebody is Obama or not, or if somebody's wearing a mask? Did you ever see me putting in all that work? Yeah, like if I take an image of a car and I want to see is it a car or not. For machine learning, a model, I might need to say, okay, does it have wheels? Does it have a roof? Does it have a steering wheel, right? I would need to put in all that work to say, okay, what is this? Is this item a car or not? Like think about those toddler games as well. Like, is this thing or not, right? Similarly, for deep learning, the exact opposite. The beauty of deep learning is that it sort of learns on its own in a way. I don't have to extract features. I can give it a bunch because I don't even know what makes a chest x-ray, a chest scan, a COVID x-ray or not. I don't know that. Like some things I will know, like what makes a person have like a COVID mask on or not, but other things I won't. And the idea is that feature extraction is done within the model itself. So it's actually going to learn from those pixels what features are important. It's actually doing the thinking that, okay, these are all, like each time in backpropagation when it makes mistakes, it's doing recalculation and figuring out. So in machine learning, you need to actually sit and think about the features you want. Like, is something a car or not? Does it have a roof? Does it have windows? Does it have maybe two, three, four wheels? Does it have a steering wheel? Does it have like, you need to think about what features you want if you're trying to figure out is something a car or not, in a model. But in deep learning, if you're given an image of a car, in deep learning, you can just give a bunch of images of cars and a bunch of images that are not cars. And then you can train, the model is going to try to figure out some characteristics. So it's going to do feature extraction in and of itself. You know the protein folding problem that I told you guys about, right? Think of it this way. If we actually knew how the 3D shape of proteins is, then why would we have an AI do that for us? The thing is, we don't know. We told the AI we figured out the shape of about 100 shapes, 3D shapes of proteins in our body for about 170,000. Scientists have done it, used experiments, and used inferences and properties. But what would often happen is that a scientist would come up with, okay, this is the 3D shape of a protein. This is how I got it. Write a paper. It will be in good journals around, good publications. Bam, I'm done. Guys, this is how I came up with the shape of my protein. These are the rules I think are important to predict the shape of a protein from a sequence of amino acids. So don't worry, that's just saying like in our body, what are the shapes of proteins? So they can say this is how you can figure out the shape of proteins. But what would often happen is it like reverse engineering. Like, okay, guys, this is the shape of the protein. I know the sequence of amino acids. So a sequence of amino acids, you guys will learn in biology, makes up a protein. Proteins pretty much do everything, in our body. They do everything pretty much in our body. And the idea is that like, all the cellular processes, everything that we're pretty much doing is done by proteins in some way, shape, or form. And the idea is that they tried to reverse engineer. They tried to figure out, how did they figure out the shape of the protein? How did we figure the shape out? That's what the $1 million question is. They would write papers on it. But what would happen is that people would try their set of rules and they would not be able to get that idea to work. They would say, okay, this person wrote a paper. They talked about how they went from the sequence of amino acids to the actual protein product. So let's try it on our set of amino acids. Then they would try to come up with a 3D shape. They would test it and find that it's not right. So what they realized is that it's more difficult than they thought. They can't just reverse engineer and see how one thing, it's like you reverse engineer a car, you break it apart, you see how things go together and try to figure out what made the shape of the car. And they figured out that they just couldn't do it. Then they realized it's more challenging than what they actually thought. So the idea is that they didn't know. And they just gave this input to an AI. They had to design very properly. The architecture of the, is what I said, that's where people make the big bucks. The architecture. So we have biologists working on this and we have people like, we can use AI. Why not use a neural network? Because we don't know what features are important. Why not show it these examples? On the thousands and thousands of examples that we do know, why not give it to an AI and have it learn the patterns that we can't find ourselves? You see what I mean? Why not give a bunch of images of COVID scans, chest scans, and a bunch of images of non-COVID scans and give it to a machine? It can figure it out for us, right? I can't, and even an IBM Watson, it says that most doctors can memorize maybe 100 or 200 articles of news. But what about all the thousands of articles that there are? Why not have IBM Watson be a diagnostic help for doctors? So that's what the feature extraction part is, that we may not know what are the rules for protein folding. Even if we get one protein down, it may not always work on another protein. There are a set of rules, and what gave me goosebumps is that AI figured out a set of rules that can classify nature. Somewhere that AI learned a pattern that people, if they had to study tens and tens of thousands of protein shapes, reverse engineer it, maybe they could figure it out, but that would take an enormous amount of time, maybe 50 years. Do you guys see what I mean? And they tried it a couple times to reverse engineer. People wrote papers, and this is how I got the shape. I tested it in the lab. But it takes so much time and effort. And when people tried it on new set of proteins, it wouldn't hold up. So they couldn't figure out what are the rules? Like, why does it shape this way in this case and that way in that case? But they gave it to an AI, a neural network, and they trained neural networks. They came up with an architecture that's the best, because their company, DeepMind, is a company from Google. And now they're providing this resource to all researchers around the world. They're revolutionizing. If you guys look up DeepMind, if you look up AlphaFold, which is the name of this product, it's going to be amazing. You see this? I didn't think we would get to this point in my lifetime. Artificial intelligence predict the structure of more than 20,000 human proteins. That, I think, is amazing. People didn't think they would get there. This is the same company. Do you see this, guys? Since 1953, this has remained the greatest problem that has remained unsolved since we figured out the shape of the DNA. And now your guys, if you guys have kids or your grandkids in your next generations, they might be learning in their textbook once we figure out the rules of protein folding. They might actually have to be tested on it. Who knows? In next 10, 15 years, it might be brought into high school textbooks, once the rules are figured out. So now people have to actually figure out, what does that AI know that they can't know, that they don't know? That gave me goosebumps, because guys, if you have the world's best researchers working on this problem with the best of resources, with all this funding and money across the world, and they can't figure it out, and you have an AI figure this out without eyes or ears or anything else. And there isn't, in my opinion, guys. After that, I had tears of joy. Actually, I never thought science could make me cry, but I actually cried. Like, and it was like really surprising. Like, I got super emotional watching that video because it was at that moment, like just like 8 months ago, that I realized that there's nothing that AI can't do at that point. If you can solve this, if AI can solve this, see, compared with the months or years it used to take to determine the structure of just one or two proteins, it took so much time and money and effort, and they figured out this problem. At this point, guys, if you're wondering if AI can do it, something that you're interested in, the question is just how do you put it into the architecture that you want? And I'm pretty sure it could do what you want it to do. If you can solve something like this in minutes to hours. And parallel approaches, structural biologists have also been working on this as the best of the best. The thing is that if we knew the shape of the proteins, we wouldn't be doing this, how they fold. But somewhere along the way, the AI did feature extraction. So the idea comes down to this, that when we're trying to predict if something is a car or not with machine learning, we give the inputs, we know what it is. But for deep learning, if I'm giving a bunch of images of cats or a bunch of images of Obama or anything to it, at some point it's going to figure out characteristics of Obama. It's going to figure out the pixels that are involved. It's going to learn that. That's what it does. Even the AI for protein folding, it's going to learn what it takes to determine the 3D shape. Now that's what it does. It figures out from photos. This was the big difficulty that people were having, is how do you use if, else statements to show that people are happy or not? Somewhere these neural networks, they learn the features. But what Tanvir asked a really good question, is here you can sort of see the features. If I tell you I have a model that can predict, your SAT score, and it looks at this, or I have a model that predicts if something is a car, and these are the features it looks at, number of wheels, steering wheel, does it have a logo, blah, 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 right? Number of seats. I can tell you my model, I can see it. But for this, part of the issue with deep learning is that sometimes we don't know what features it's learned. It gives us tremendous power, but sometimes people are like, I might just want something simpler. Like, it's so difficult to know what each neuron has learned. And that's why people have come up with these techniques to try to figure out and visualize, and we'll watch a little bit of this. This is my research paper, where people have tried to visualize what does each neuron do.